Let me now present you level 2 relaxation about our problem. So we have this step of x2 squared minus x1 x2 minus x2 such that x1 squared equal x1 and x2 minus x2 squared is superior to 0. So our moment matrix at level 2 is just equal to this, like you have 1, x1, x2, normally it's x1 squared as we also here, like x1 squared equal x1, so we don't have to write it, x1, x2, x2 squared. So here, 1, x1, x2, not necessary to write x1 squared because it's equal to x1, we already write it here, and yeah, x2 squared. So just 1, x1 squared, x2 squared, x1, x2 squared, x2 to the power of 4, x1, x2, x1, x2, x2 squared, x1, x2, x1 squared, x2, x1, x2 squared, x1, x2 squared. And yeah, x2 to the power of 4 of 3 and x1, x2 to the power of 4 of 3, and so I have this, and basically it's just symmetric matrix by definition, moment matrix have this, and so basically you just see here, like we also have x2 minus x2 squared is superior to 0. So at first I just want to correct this because like x1 is not squared anymore, because x1 squared is just equal to x2 squared to x1 squared. So I can just write this for now. And here too, x1 squared is equal to x1. Yeah, basically I just write down the stuff now, and we will trick to do the y stuff after, because it just take times to do this. But yeah, basically after, if you just replace like 1 being like 1, and after having like y01, y02, y03, y04, you'll just have this being beginning being y01, y02, y03, y04, and here having y01, here having y04, here having y042. Okay, browser, that was really a mess, but I managed to do it, and I can continue for the second one. But so now we have our stuff, we want y stuff, so the solver doesn't have the squares, and we can do our comic stuff. And so just x1 being y01, x2 y02, x1, x2, y03, x2 squared y04, and so it just gives us here y02 minus y04. Here to give us like, oh bro, it's literally a mess. Oh, y02 minus y04. Second step is like x1, x2 minus x1, x2 squared. x1 is y0, x1, x2 is like y03 minus x1, x2 squared, which is like minus x1, like this is 0,1, x2 squared is 4, so it's like minus y1, 4. The last one is 2 squared, so it's just y 0, 4 minus x2 to the power of 3, so it's like y1 4 y2 4, and so for the second line, so blah blah blah. Let's show more times. X1 x2 like here will be like y, so it's x1 x2 it just y0 3 minus x1 x2 squared. It's like y1 4, like it's literally the same as up. After x1 x2 squared just y1 x1 x2 squared just y1 x1 x2 squared just yeah, y1 multiplied by 4 now, y1 4 minus x1 x2 stuff, so I think it can be like y3 4. And the last one is 2 to the power of 3. It's just like, for me, y2 4 minus x2 to the power of 4 is like y4 4. And so that's semi-positive definite. And so yeah, and if we remember, we had the sep of x2 etc. So it's just the sep of, so x2 squared, so it's like y 0 4 minus x1 x2 is like y0 3 minus x2 is like 0 2. So yeah, such that we have those two constraints. And so seeing this SDP, we get a numerical value of 10 to the power minus 8. And indeed, so the optimal value of the optimal problem is 0. So yeah, we'll just see here that the hierarchy converges quickly. So yeah, that's great. It was hard but cool. Like we see, it's converged because it's the first level 1 is where we have like 1/8, and here is like, so it was 0.125, and now it's like 10 to the power minus 8. 10 to the power minus 8 is like 0.00001, like 0.000000001. And so, well, you got me, maybe I was missing enough 1 or 2 zeros, but like, yeah, 0.000000001. And so, yeah, we see like it will be more and more precise, but like we see it will be converted to 0. And so, yeah, that's just why we can say the optimal value of the polynomial problem is 0, and the hierarchy has converged quickly.